Welcome to this video on number systems and number conversions. This is a review of binary, decimal, and hexadecimal. For starters, let's look at some of the rules of number systems that we discussed in class. The value of a digit in any number system is not equal to just the value of the digit. It is equal to the digit times its place value. So for example, the number 591 is just not 591. It's equal to 5 hundreds, 9 tens, and 1 1, which is why we call it 591. The next rule is the number of digits in the number system is the same as the base. For example, the decimal system is called base 10, and there are 10 digits in the decimal system. The next rule is the place values of a number system are powers of the base. The place values for base 10 are 10 to the 0 on the right, 10 to the 1 in the middle, and 10 to the 2 on the left. And if you remember, we can go on to the left by adding more place values, but we'll stick with these. 10 to the 0 is 1, 10 to the 1 is 10, and 10 to the 2 is 100, which is where we get our ones, tens, and hundreds place. We can extend this knowledge to binary and hexadecimal. First of all, let's look at decimal again. The base is 10. There are 10 digits from 0 to 9. We're going to use 3 place values. Just like on the previous slide, those are going to be the tens place, the ones place, the tens place, and the hundreds place. The maximum value of this number that we could write in, any number we could write in these 3 place values is 999. But we're going to limit ourselves to 255, as you'll see on the next row of the table. In binary, which is base 2, there are 2 digits available, 0 and 1. We're going to use 8 place values to make our numbers. And the place values are going to be powers of 2, which are 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, and so forth. So these are the place values for binary. If you put ones in all of these digits, you will find that the total of the largest number you can put there is 255. We're going to see how you get that in a moment, but you basically add up any of the places where there's a 1 on it, you add up the place value. If you add these all up, you get 255. Hexadecimal is base 16. Just like the other number systems, the base tells us how many digits there are. Since we want to write a digit in a single position, we're going to use extra made-up digits. 0 through 9 are the same as the decimal 0 through 9. But when you get to 10, 11, 12, 13, 14, and 15, those are replaced by A, B, C, D, E, F. We'll see examples of that as we go through the presentation. In the hexadecimal number system, we're only going to use 2 place values. And their values, the place values, are going to be 16 to the 0, which is 1, and 16 to the first power, which is 16. Now, the largest number you can write in these 2 digits in hexadecimal is FF, because F is the highest digit, and we're going to put it in both place values. Now, I told you that hexadecimal has 16 digits. The first digit is 0. The last digit, F, represents 15. So if you multiply 15 times 16 and 15 times 1 and you add them up, you'll get 255. Now let's look at the conversions. We're going to go through conversions between, we're going to do 6 types of conversions. We're going to start with binary to decimal. A binary number is a sequence of ones and zeros. As I mentioned, we're going to use 8 digits, so here's an example of one. 1001, 1101. To convert this to a decimal number, write the place values below each digit like this. Now, every place you see a 1 in the number, you're going to add the place value like this. You see there's a 1 on top of 128, 1 on top of 16, 8, 4, and 1. So if we add those numbers together, we get 157. So 1001, 1101 in binary is equal to 157 in decimal. Now let's go to decimal to binary conversions. When we do decimal to binary, let's just write these numbers here, and I've drawn them as blocks. The decimal numbers we'll use for conversion in our class are between 0 and 255. For example, the decimal number 213. Imagine you have the following numbered blocks, and you only have one of each. To convert 213 to binary, you need to pick which blocks you need to make the number. Whichever blocks you pick should add up to 213. Here's how we do it. Start with the largest place value, 128. Do you need 128 to make 213? Yes, because 213 is larger than 128, so we will need that block. So we'll put a 1 on top of 128. Now we've made 128 out of the 213. So what's left over to make up with the other blocks? It's 213 minus 128. So using the other blocks, we have to make up 85. Now let's go to the next block. Do we need 64 to make 85? Well, yes, 64 is less than 85, so we will need that. So we'll put a 1 on top of the 64, and then how much will be left? We've made 64 out of the 85. We're going to subtract 64 from 85, and we only need to make 21 more. So we'll go to the next place value. Do you need 32 to make 21? Well, no. 32 is greater than 21. If we put that in, it will make the number larger than we want. So we're going to skip 32 by putting a 0 on top of 32. So we still have to make the 21. We'll go to the next place value and say, do we need 16 to make 21? Yes, we do. So we'll put a 1 there, and we now have how much left over? Well, out of 21, we've just added 16, so we only need 5 more. So let's continue to the next place value. We need to make 5. Do we need 8 to make 5? No, 8 is too much. So we're going to put a 0 on top of the 8, and we still have to make up 5. Now we go to the 4's place. Do we need a 4 to make 5? Yes, we do. So we'll put a 1 on top of the 4, and that leaves 1 left over. Do you need 2 to make 1? No. So we'll put a 0 on top of the 2, and you still need to make up 1. We go to the next place value. Do you need 1 to make 1? Yes. So you put a 1 on top of the 1. 213 in decimal is equal to 11010101. Great. Let's continue. Let's convert hexadecimal to decimal. The hex numbers we will use are 2-digit numbers. The digits in each place value can range from 0 to F as shown in this table. Let's take the example of the hex number 3B. To convert this to a decimal number, we write the place values below each of the 2 digits like this. Then we multiply each digit by the place value. 3 times 16 is equal to 48. And b times 1, well, b times 1 is the same as 11 times 1. If you look at the chart, b is 11. So we'll say 11 times 1 is 11. And then we'll add 48 and 11 and get 59. 3b in hexadecimal is 59 in decimal. Now let's see how to convert decimal to hexadecimal. I'm going to keep this handy chart next to us here, and we'll take the decimal number 59. To convert 59 to decimal, start by writing the hex place value as shown. We'll write our digits on top of these lines as we calculate them. Next, divide 59 by 16. 59 divided by 16 is 3.6875. We're going to ignore the numbers after the decimal. So we're going to take the 3 and write it on top of the 16's place. So what we're saying is that there are 3 16s that will get us close to 59. If we had used 4 16s, that would be 64, and that would be too big. So we've got 48 out of 59 represented by putting that 3 in the 16's place. We now want to subtract 59 minus 48 to see what's left over. 59 minus 48 is 11. So we'd want to write 11 over the ones place, but 11 is not a hexadecimal digit. So instead we have to look at the table on the right and see that 11 is equal to B in hexadecimal. So we're going to write a B on top of the 1, and 59 in decimal is equal to 3B in hex. In either step, we're either dividing by 16 or by subtracting the original number minus whatever digit you put in the 16th place. If the number is greater than 9, use the table on the right to substitute the letter for the number. Now let's look at converting binary to hexadecimal. There's a pretty cool trick you can use to convert binary to hexadecimal. Looking at this chart here, you'll see that there's a column for decimal, hexadecimal, and binary. And I've only put 4 bits of binary here, and you'll see why in just a moment. Let's take the binary number 01011010 and convert it to hexadecimal. First, split the binary number in half like this. Look up each half of the binary number in the chart on the right. When you find it, write the hex equivalent under the binary. So, let's look for 0101, which is next to the 5 in hex. And so under the yellow, we're going to write the number 5. Now let's look up 1010. 1010 is next to A in the hex column. So we're going to put A under the 1010, and we are done. This number 01011010 is equal to 5A. And that's all there is to that. Converting from hexadecimal to binary is similar. We use the same chart. Let's take the number C8, the hex number C8, and convert it to binary. Similar to how we did it on the previous page, we're going to write the number C8, and then we're going to look up C in the table and 8 in the table. C is 1100, so we'll write that under the C. And 8 is 1000, so we'll write that under the 8. And that's the number. C8 in hexadecimal is equal to 11001000 in binary. I hope this video has been helpful to remind you how to do conversions in hexadecimal, binary, and decimal. If you need to go back and review this video, you're welcome to. You can also contact me with questions.